Same, but different. Yeah. This in this integral we have logarithm integral function as well as log of x in this product. Yeah. And we have to integrate it. And the answer is pretty beautiful. Log of 2 minus 1 by 2. Yeah. Now, if you don't know about the Li function, the Li of x is defined as the integral from 0 to x of 1 by ln of t dt. The definition of Li function. And normal trick to deal with Li function is just to make an integral in this way, integral from 0 to infinity of e to the power minus ln t times a by ln t dt. Yes, and then it's easily evaluate if you find ideas of a, yeah, because ln t cancels out, and our aim would be to find I of 0 at last, because okay, no, not infinity over here. This is x. Sorry, this is x. Yeah, and our aim is to find I of 0 because this goes to 1 then 1 by ln dt, which is our required Li of x function. Yeah, to find Li of x, just find I of 0. So this is our normal trick that we use while dealing with Li function in most of the cases, and here also we will do the same. Okay, now we will write this as I of a is equals to integral from 0 to 1 log of x and the integral from 0 to x e to the power minus ln t times a by ln t dt and then dx. Our aim would be to find I of 0. Yes, good. Now, what we can do is we can try to differentiate this with respect to a. Find ideas of a. Integral from 0 to 1 log of x integral from 0 to x e to the power minus a ln t and then minus ln t by ln of t dt dx. Ln t cancels out and minus comes in front. So we have idence of a is equals to negative of the integral from 0 to 1 log of x and the integral from 0 to x of e to the power minus a ln t means e to the power minus a to the power minus a dt dx. Okay, now then we have idence of a is equals to negative of the integral from 0 to 1 log of x. Its integral is e to the power minus a plus 1 by minus a plus 1, and that goes from 0 to x dx. Okay, and now we can take this constant outside 1 by 1 minus a integral from 0 to 1 log of x, and that will just be x to the power minus a plus 1 minus 0. Yeah, dx. Good. Now we let y is equals to minus log x, because only then it will go from infinity to 0. Y equals to minus log x. Yeah, and idence of a is equals to minus 1 by 1 minus a, and then this is from infinity to 0, and then this is just minus y, and now this is e to the power minus y times minus a plus 1 dx is e to the power minus y times minus dy. Yeah, and then we have idence of a is equals to minus 1 by 1 minus a. Now over here the minus and minus sign cancel out, and this minus sign over here can be used to reflect the limits of integral. Yeah, this minus sign over here can be used to reflect the limits of integral from 0 to infinity. This 2 and minus cancel each other out, so we have e to the power minus y times 1 minus a by times y dy. Is that it? Okay, no, actually no. Okay, so yeah, this is 2 minus a, because minus y times this and minus y times 1 again, so minus is equal to minus a, very good. And then y dy, yes. Yeah. Now assuming that a is less than 1, yeah, in which case this will always be positive to minus a. We can now do this, yeah, with this assumption, and we get I times of a is equals to 1 by 1 minus a, and since finally we are going to put a at 0, this assumption will like not be of any trouble to us, because there is of course less than 1, yeah. And then now this will just be gamma of 2, yeah, this is just 2 minus 1, yeah, so gamma of 2 by this is 2 minus a to the power 2. Am I correct? Yes. And okay, so we have reached this range. Now we just need to do some partial fractions, and after partial fractions it will be simplified. 1 minus a, 2 minus a whole square. Now if we do the partial fractions, I think you all know how to do it. We'll do it with the reading now. 1 by 1 minus a, 2 minus a square. We know that this will break down into a by 1 minus a plus b by 2 minus a plus b by 2 minus a squared, yeah, and this will be 1 equals to a times 2 minus a squared plus b times 1 minus a 2 minus a plus b times 1 minus a, yeah. Is that good? Yeah, good. Now if we can replace a is equals to 1, that makes both of them 0, so we have 1 is equals to a times 2 minus 1 is 1, 1 squared, so we get a equals to 1. If you replace a as 2, both of them over here will be 0. Now this one will be 1 is equals to b times 1 minus 2 is minus 1. Is it? Yes. So it's minus 1. So b is equals to minus 1. Now if we replace a is equals to 0, this will be 1 by 1 into 2 square. Sorry. I'm sorry, pretty sorry. I'm sorry. Now if we replace this by 0, we get 1 is equals to a times 2 square is 4 plus b times 2 plus, oh my god, it should be c, not b. It should be c. It should be c. Sorry. No, this should be c. This should be c. Yeah. And now this is c times minus 1, not b times minus 1. It should be c. It should be c. Good. Okay. Now b times 2 plus c times 1. You know that a is just 1 and c is minus 1. So we get 1 is equals to 4 plus 2b minus 1. 1 is equals to 3 plus 2b. Take this to other side. Minus 2 is equals to 2b. So b is also minus 1. So a is 1, b is minus 1, c is minus 1. So we get now ideas of a is equals to 1 by 1 minus a minus 1 by 2 minus a minus 1 by 2 minus a square. Is that? Yes. Now if we take an integral, we will have I of a is equals to ln of 1 minus a by minus 1, and then this will just be plus ln of 2 minus a, and this will again be minus of 2 minus a to the power minus 1 by minus 1 times minus 1. Okay, good. Now, and then again we'll also have plus over here. Yeah. So now we can say that we will have I of a, and now this is just ln 2 minus a by 1 minus a, and then this is minus cancel out, minus 1 by 2 minus a, and then plus c. Yes. Yeah. Now we need to find c. For that, we know that when a goes to infinity, we know that I of infinity is just 0. Using that, we get I of infinity is just 0. I of infinity, which is actually 0, over here. This should be ln of infinity by infinity is ln of 1, which is 0, and minus 1 by infinity is also 0. So this is 0 equals 0, 0, 0 minus 0 plus c, so c equals to 0 clearly. And we see that I of a will be ln of 2 minus a by 1 minus a minus 1 by 2 minus a, 2 minus a plus c. Yeah. Already we assume that a is less than 1, so we can clearly use a at 0 here now, because our assumption isn't really out of bounds sort of thing. That was clearly helpful. Now I of 0 is our required answer is ln of 2 by 1, which is 2, minus 1 by 2, and c is already 0. So this is our answer. This is how we got the solution. I of 0 is ln of 2 minus 1 by 2, which is the required answer. And this was a pretty interesting integral, the product of the Li and the log, and this is super amazing problem. We just used the normal trick that we have been using from the very beginning, and all of this was just gamma function and partial fractions and normal integration. So that was it. Hope you enjoyed the video. Thanks for watching and look forward to seeing you in the other exciting integrals as well.